Hello. So we want to make some lines of reflection here to be able to make a rotation. And before I teach you that, I just really want to have you understand why we're doing what we're doing rather than just going through the steps, understand what we're trying to find here. And it'll actually be helpful in later units. So for example here, give you two definitions here, concentric circles and the chord center theorem. Concentric circles are what I've drawn here is that they're just circles that share the same center. But then this chord theorem or chord center theorem we're going to use in Unit 6 actually. It says the intersection of two perpendicular bisectors of any two chords meet at the center. Now if why I give you these is a rotation is essentially this. You have a triangle and what it does is all these points rotate around these concentric circles. Now why we can use the chord center theorem is all three of these circles share the same center. So, you did that extra credit problem, hopefully, or some of you did, some of you didn't, that I can find the center of a circle using triangles. That, for example, if I draw this circle here, if I draw any triangle inside of it, say this one to this one, this one to this one, this one to this one, we're finding the circumcenter because this is a circumscribed circle now. Well, it's the same thing. Think of these are two chords. Chords are just any 2 points that connect any two vertices of a triangle. So if I find the perpendicular bisectors, where they meet will be the circumcenter, and that'll be the center of my circle. Well, I'm doing the same thing in this picture. It's just that what we're doing here is we're connecting corresponding vertices of the triangles. That was our first step. Well, by doing that, I'm actually making a chord of the circle. And then I'm making a chord of this circle. So if I connect all these corresponding vertices, all I'm doing is making chords of these concentric circles. If I find the perpendicular bisectors, they should meet in the center. All right, so let's construct a rotation of this picture here. So first thing I'm going to do is connect those corresponding vertices. So C looks like it rotated all the way around to R. A looked like it went all the way to P. Now I'm only going to find the perpendicular bisectors of two of them just to save some time, and you only do have to find two of them. I'm going to find the perpendicular bisectors using my compass, and you can use a ruler, you can use a protractor, either way is fine. On a smartboard this is, I would say, equally as fast. So let's go, if making sure it's long enough here. Down here. So again, what I'm trying to do is find 2 points that are equidistant from my endpoints. There's one point that's equidistant from my endpoints, there's another one, and I'm going to connect these with a green line. And that should be the perpendicular bisector. Looks like I'm a little off down here. That's all right. All right, do the same thing over here. That's close enough. So notice I kind of did it two different ways, but all I'm again looking for is a point that's equidistant from those endpoints, and these circles have that same radius. So there we are. Okay, we have essentially this point right here is all I need to know. I'm going to highlight it as point O. That's going to be the center of my circle. Now, it might take me a little while here, but I'm going to delete most of this stuff that I don't need. Definitely don't need that. But after all this stuff, I don't need these markings anymore. All this showed me was where the center of my rotation is. I need that though. All right, so I have the center of my rotation. Now there's ways to measure angles also, but essentially we got to think about again, C is rotating all the way to R. So again, the intersection of the perpendicular bisectors finds you the center because of this previous picture. I'm finding the center of these concentric circles, but now I'm going to actually measure how big of an angle it actually rotated. So now I'm going to connect C to O, because I'm going to connect C to O and then O to R to see what angle all of these rotated. Now, if you want to connect A to O and O to P, you're finding the same angle. This one's just going to be easier for me to measure on here. So if I grab this, try and line it up nicely here, it looks like my angle is about, for ease I'll go 114. Okay, so we'll say this is 114 degrees total. So again, one of our other relationships that we know is the angle of the angle between our reflection lines is half of that total rotation. So half of 14, we have 67 degrees, or sorry, 57 degrees. Should probably get that right. 57 degrees would mean I have to have any two reflection lines with an angle of 57 degrees in between them. Now, to be honest, it's arbitrary where you put them, as long as there's 57 degrees between them. So you know what? I'm going to have one of my reflection lines go through 50. I'm going to use this 50 degrees as a reference, which means my other one is going to be 57 degrees away from that, so it's going to be at 107. Again, the angle in between has to be 57 degrees, and that's this angle right here, in between these two blue dots. So these are my reference points. If I take this protractor away now, that angle is 57 degrees if I draw some lines through O. So the blue lines I'm going to take away because that was the total 114. Those are not the reflection lines. But right here, if I connect O to this blue dot and O through this blue dot, this is the angle of 57 degrees, and I'll extend them this way. Make sure to actually extend them and not make a new one. These are my reflection lines. And you can check your work. And checking your work, I'm not going to be too picky about, but see if it worked. If this is my first reflection line, I would reflect A across here. So let's go perpendicular, have the same distance as best we can. Like I said, this one we're not going to be as exact. Let's grab that. Oops, sorry about that. So now A is over here, and then we'll call that A prime. But then it's going to reflect all the way over to P. So if I go perpendicular to P, as best I can, like I said, visualizing it, that looks pretty close to perpendicular. We'll see if it actually ends up rotating all the way to P. And that's pretty darn close. I would be plenty happy with that as my reflection lines. So again, as a recap, we have to find two reflection lines. To do that, we connect corresponding vertices and find the perpendicular bisectors. That finds the center of those concentric circles. It finds the center of our rotation. From there, we measure the total angle. In my case, it was 114 degrees total from C to O to R. But that means the reflection lines have to be half of that. So in between here is actually 57 degrees, making a total clockwise rotation around center O of 57 degrees. Right, hopefully this helps. Try some extra practice. I think this is maybe the picture from number 13, but you can always draw those two rotations and then try and find your reflection lines. Hope this helps. Have a great time, guys. See you later.